things we love about managing lightweight access points as opposed to autonomous access points is that if we have a large wireless network, maybe we have an enterprise location with multiple buildings and multiple access points, with a lightweight access point approach, we can go to a wireless LAN controller and configure lots, if not all of the APs in our enterprise. That's as opposed to individually configuring them with autonomous access points. However, in an enterprise network, we probably have some access points that need to be configured differently than other access points. So the goal is to be able to have a granular level of control on our enterprise's access points without having to go to the extreme of configuring them individually. For example, let's say in these two buildings, only that top access point in building one, only it should be advertising the SSID or the wireless network name for the research and development department. The other 7 access points should not be advertising that. Maybe all of the access points in building one should support the 5 and 6 gigahertz bands, but not the 2.4 gig band, while all 3 bands should be supported in building 2. And let's say that our CapWAP settings, like different timers, are different between the different buildings. And in this video, we want to consider a strategy for accomplishing a goal like this. And the solution is to segment our wireless networks with profiles, tags, and then we can group access points together that have the same set of tags. First of all, let's consider a profile. And there are different categories of profiles, and each category describes a particular characteristic of our wireless network. And within that profile describing that characteristic, there are a set of parameters that we can set. Let's take a look at the profiles that Cisco supports. One type of profile is a wireless LAN profile, sometimes called an SSID profile, because it controls what SSIDs or wireless network names get advertised. And this is not a comprehensive listing, but it controls things such as how the client authenticates with the network. Is it going to be using a pre-shared key? Is it going to be using 802.1x to authenticate with a Radius server? Or is it going to be doing WebAuth? Another type of profile is a policy profile, and as a couple of examples, it contains information about VLANs and quality of service settings. There's the AP profile, or some literature calls it the AP join profile. This can have information about our CapWAP settings, such as various timers. It can have information about our power over Ethernet settings. And if we're using Cisco FlexConnect, which allows us to have a wireless LAN controller maybe at the headquarters and control wireless access points that live at remote sites, well, those settings can be specified in the Flex profile. There's an RF profile for radio frequency. This can control what channels we're going to be using and the transmit power levels. Those are the profiles that we can have, different categories of wireless LAN characteristics, and then we can group these profiles into different tags. And there are 3 types of tags. The first one is a policy tag. This is going to link the wireless network name, the SSID, the service set identifier. It's going to link that SSID to the policy profile. Our second of 3 tags is the site tag, and that tells us whether or not an access point is being controlled with a local wireless LAN controller, that will be local mode, or if it's being controlled by a wireless LAN controller at another site, running in FlexConnect mode. And this site tag also contains the AP join profile and the Flex profile that might be applied to an AP. And finally, we have the RF tag, the radio frequency tag. This can be used to specify what bands of frequencies we're using, as well as some of the settings within those bands. And what we can do is take a set of tags and apply them to an access point. And we might have multiple access points that need the same set of tags. Well, we could logically group them together in a group. A group is a collection of one or more access points that need a common set of tags. Remember that top access point in building 1? It was the only access point that was supposed to advertise the research and development SSID. So we might put it in its own group and give it its own set of tags. And the policy might be called policy RD for research and development. And we might have the same site tag for all 8 of these access points because they're all at the HQ site. And we might have an RF tag of 1. And that could be applied to all of the access points within building 1, remembering that those access points do not support the 2.4 gig band, but the APs in building 2, they do. And for the remaining APs in building 1, they could be put in a group and assigned this set of tags. The policy could be the general policy for all HQ access points, with the exception of the R&D access point. And all of our access points we said are going to be sharing the site HQ tag, and we'll also give this the RF1 tag. 4 gig band, and then we can group together all of the APs in building 2 and give them this set of tags. They can all be assigned the policy HQ tag, and just like all of the APs in building 1, everybody's sharing the site HQ tag in this example, but the APs in this building, they should support that 2.4 gig band, so we'll give them a different RF tag, RF2, which will include the 2.4 gig band. And that's a look at how profiles, tags, and groups give us the best of both worlds when we're comparing autonomous versus lightweight access points. By using profiles, tags, and groups, we don't have to configure all of the APs one at a time, but we can do granular configuration when we need to.